In this video, we'll quickly go through vectors resolution. In the previous video, we already talked about vectors addition and subtraction. However, at many times it becomes convenient for us to resolve the vectors before doing the addition and subtraction, and therefore in this video we will learn how to resolve vectors into its component form before we can add or subtract or do any other mathematical operations. So let's get started. So let's begin with resolution of a vector in two dimensions. Let's imagine that this is our coordinate axis. That means this is the x-axis and this is y-axis, and a vector is such that it lies in the xy plane and that the vector is making an angle theta with the positive x-axis, and the magnitude of this vector is equal to a. So we can resolve this a vector along the x-axis and along the y-axis. We will say that a part of this vector is along the x-axis, and that is this part, which we call it ax, and a part of this a vector will be in the y direction, which is this part. We call it ay. So this a vector can be written as in the component form that how much in x, it is ax in the x direction. So we call this in the x direction as I cap, which is the unit vector in the x direction, plus how much in the y direction, it is ay in the y direction. So it is ay j cap. And what is this ax? If you look at the geometry, it is nothing but a cos theta. And what is ay? It is a sin theta. And therefore a vector can be resolved along x-axis and y-axis in this manner that the x component becomes a cos theta and the y component becomes a sin theta. So in order to resolve any vector along any two mutually perpendicular directions, you just need two things. Number one, you need magnitude of that vector. In this case, the magnitude of the vector is a. And secondly, you need the angle made by that vector with any of the two axes. Well, if you know that, then you can resolve the vectors by taking its component in the two mutually perpendicular directions. So here it is a cos theta I cap plus a sin theta j cap. In this manner, we have broken down this a vector into its component. Let's now have a look at few special situations. The first situation is, let's imagine that there is a vector of magnitude 10 units in the right direction, which is the positive x-axis. Then this a vector will be equal to 10 I cap and no component in the y direction, because this vector is completely in the positive x direction. Let's imagine that this is your 10 unit vector which is completely in the positive y direction. So now this a vector is going to become equal to 10 j cap and no component in the x direction. Now if the situation is like this, that this vector is towards the negative x direction, then in this case the vector will be equal to minus of 10 I cap. This minus sign is indicating that the x component is negative and definitely no y component is there. And if the situation is such that the vector is completely in the direction, then the vector can be written as minus of 10 j cap and no x component will be there because it is completely in the y direction. So apart from these situations, let's say the vector is somewhat like this. That means it is in the first quadrant. Well, if this situation is there, then in this case the x component is going to be positive as well as the y component is going to be positive. And if the vector is lying in the second quadrant, then in this case you can see that the x component is going to be negative whereas the y component will be positive. And if the vector is in the third quadrant, then in this case the x component as well as y component, both of them are going to be negative. And if the vector is in the fourth quadrant, then in this case the x component will be positive whereas y component will be negative. And how to find out this x component and y component? Well, as I said, you just need to find out what is the angle made by this vector with either with the x-axis or with the y-axis. If it is making, let's say, theta angle with the x-axis, then for writing the component of vector along x-axis you will use cos theta, and for the y component you will use sin theta. And if the vector is making theta angle with the y-axis, then for writing the component along y-axis you will use cos, and for x you will use sin. So in this manner you resolve these vectors along the x-axis and along the y-axis. We will see what is the benefit of resolving these vectors along the two mutually perpendicular directions like this. So let's now talk about the resolution of vector in 3 dimension. That means in this case the vector was lying in the xy plane. What if the vector is not lying in the xy plane, its orientation is somewhere in the space? So let's see, in that situation, how do we resolve the vector? So let's now imagine that we have a vector which is neither in the xy plane, nor in the yz plane, nor in the xz plane, and therefore in this case this vector is going to have some x component as well as y component and as well as z component. It is unlike the previous case where we were discussing resolution in 2 dimension, in which the vector was either in the xy plane or in the yz plane or in the zx plane. For example, if the vector is in the xy plane, the vector will not have any component towards the z-axis, and therefore it will have only x and the y component. However, in this situation the vector is going to have x component, y component and z component. All of them are going to be there. So how to find out the components of this vector along x-axis, along y-axis and along z-axis? We will require two things. One is magnitude of this vector, which is a over here, and secondly we will require what are the angles made by this vector with the positive x-axis, positive y-axis and positive z-axis. Let's imagine that the angle made by this vector with the positive x-axis is alpha, with the positive y-axis it is beta, and with the positive z-axis it is gamma. So if we know these angles and the magnitude of this vector, we can resolve this vector and find its component along the x-axis. So first of all, let's try to see in this figure what is the component of this a along the x-axis. Well, this distance is going to be the component of a in the x-axis, and this distance is going to be the component of a along the y-axis, and this component will be the component of a along the z-axis. You can see, you can use the polygon law of vector addition to see that the summation of ax plus ay plus az is actually equal to a vector, and this ax is the component along x-axis. What is this ay? Basically this is parallel to the y-axis, and this az is parallel to the z-axis. So we can write that this a vector is equal to ax I cap plus ay j cap plus az k cap. Now what is this ax? Ax is a cos of alpha I cap, and then we have a cos beta j cap, and then we have a cos of gamma k cap. K cap is a unit vector in the direction of positive z-axis. So we just need the magnitude of the vector and the angles made by this vector with the positive x, y and z axis, and in fact we just need 2 of the 3 angles. If we know alpha and beta, we can find out gamma, because we do have a spatial relation between alpha, beta and gamma. That means if you look at this cuboid, the diagonal length is a, the sides are ax, ay and az. So if you do ax square plus ay square plus az square, it has to be equal to a square, and therefore we get a relation between alpha, beta and gamma as cos square alpha plus cos square beta plus cos square gamma as equal to 1. So as far as the terminologies are concerned, you know what is a cos alpha, a cos beta and cos gamma. They are the x component, y component and z component of the vector in the x, y and z direction respectively. What are alpha, beta and gamma? They are the angles made by this vector with the x, y and z axis respectively. And what is cos alpha, cos beta and cos gamma? It is important that cos alpha, cos beta and cos gamma, they are called as direction cosines. So now we have understood how to resolve a vector which is neither in the x, y, y, z or zx plane along the x direction, along the y and along the z direction. All we just need is the magnitude of the vector and the angles made by the vector with the x, y and z axis. So this is all about resolving a vector, whether in 2 dimension or it is in 3 dimension. Now we will see the situation if we already have the vectors in the component form, then how to find out its magnitude, how to find out its direction, that is to say what angle it is making with the x-axis, with the y-axis or with the z-axis. So let's see if a vector is already in the broken form, in the component form, in the resolved form, then how to find everything about that vector. So now we have a vector which is already resolved. Let's take the first situation in which we have a vector which is written as ax I cap plus ay j cap. It means that this vector does not have the z component. So let's talk about the magnitude of this vector. The magnitude of this vector will be equal to ax square plus ay square whole under root. Now what about the direction of this vector? Well, the direction of this vector, one thing is very much sure, that it is making 90 degree with the z direction. That means it is not having any component along the z axis, and therefore the vector is making 90 degree angle with the z direction for sure. What about its angle made with the positive x and with the positive y axis? Well, for that you just have to draw the vector ax. If let's imagine that both are positive, if both of them are positive, then this is going to be ax, this is going to be ay will start from where ax is ending, and therefore this is going to be your a vector. And let's say this is the angle alpha which it is making with the positive x-axis, and therefore tan alpha will be equal to ay by ax. So if you want to find out the value of alpha, it is going to be equal to tan inverse of ay by ax. So whenever you have such a situation, what you need to do in order to find the magnitude, you simply use this formula, and in order to find the direction, you actually draw this vector. If ax and ay both are positive, then this is how it will be done. If let's say ax is negative and ay is positive, then you will draw it in this manner. Ax will be negative and ay will be positive. So this is going to be the a vector. So this was a situation when we had a vector and its component only in the x and y, or let's say in the yz or in the zx. What will happen if we have components along all the three directions, that is x, y and z? Let's see that situation. So basically we have a vector as equal to ax I cap plus ay j cap plus az k cap. When we have this situation, then the magnitude of this vector will be written as ax square plus ay square plus az square under root. And what about the direction? Well, for direction, we actually need to find out cos alpha, cos beta and cos gamma. So what are the direction cosine? The direction cosine will be cos alpha will be equal to ax divided by a, and a we have already calculated from the above formula. Cos beta will be equal to ay divided by a, and cos gamma will be equal to az divided by a. So if we have a vector which is in the resolved form, in this manner we can find the magnitude of the vector, number one. Number two, the direction cosines can be found by using this. And there is one more way in which we can express the direction of the vector. We can express the direction of the vector in the form of unit vector. So if we have a vector written in the component form, how to write the unit vector in the direction of a vector? Let's talk about that. So if we have a vector a vector equal to ax I cap plus ay j cap plus az k cap. What is the unit vector in the direction of a vector? Unit vector in the direction of a vector will be a vector divided by magnitude of a vector, which is equal to ax I cap plus ay j cap plus az k cap divided by magnitude of a vector will be under root of ax square plus ay square plus az square. So this is how we will write a unit vector in the direction of a vector if the vector is given in the component forms like this. Let's now see how to write the sum of two vectors or difference of two vectors or any other mathematical operations for that matter when we have a vector in the resolved format. So let's imagine a situation where we have two vectors which are either already in the resolved form or we have resolved it for our convenience. And there are various mathematical operations that we can do. For example, if we want to do addition, that means we want to find out a vector plus b vector, then it is simply the addition of the x component I cap, addition of the y component j cap, addition of the z component k cap. So conveniently we can write it as ax plus bx I cap plus ay plus by j cap plus az plus bz k cap. And in fact, if we call this a vector plus b vector as a resultant vector, or we can call it by some other name, let's say c vector, then it is equal to the x component rx will be ax plus bx I cap plus ry j cap plus rz k cap. So this is going to be the resultant vector of a vector and b vector. Now if you want to know the magnitude, we have already seen the formula would be under root of rx square plus ry square plus rz square. If you want to know its direction, you can find out the direction cosines. If you want to find out a unit vector in the direction of this r vector, you can also find that out. We already talked about that formula. Let's talk about what if you want to do the difference of the two vectors. That means you want to do a vector minus b vector. Well, you can already guess it. Let's talk about that. So if you want to find out what is a vector minus b vector, this is going to be equal to ax minus bx I cap plus ay minus by j cap plus az minus bz k cap. Again, we can call this a vector minus b vector by some other name. Let's say it is c vector. So c vector will be equal to cx I cap. Cx is ax minus bx plus cy j cap plus cz k cap. And now we can find everything about this c vector, which is nothing but a vector minus b vector, depending upon what is our requirement. So we have talked about the addition of the two vectors given in the component form, subtraction of the two vectors. Now we can talk about multiplication of this vector with any scalar quantity, and let's see how it becomes. So basically, let's say we multiply this a vector by 3, so it becomes 3a vector, and we can multiply b vector with 2, so it will become 2b vector. And let's say we want to add these two things, so it is very easy. It is going to become 3 times ax plus 2 times bx times I cap. Similarly, the y component will get 3 times ay plus 2 times by j cap, and similarly the z component will become 3 times az plus 2 times bz k cap. Now you can call this component as cx, cy and cz, and you can actually find out the magnitude of this resultant vector, which is 3a vector plus 2b vector. Or if you want to find out the direction cosines or unit vector in the direction of 3a plus 2b, you can also do that. So you have seen that in this manner, the resolution of the vectors actually help us. It is convenient for us to add two vectors, or in fact more than two vectors. If it is there, then it is very convenient to use the resolution of vectors. If we want to add, subtract, or whatever we want to do, we can do it conveniently, and finally we will get a vector also in the component form, but we can find out what will be its magnitude as well as its direction. Well, this is all about resolution of vectors, and if you wish to solve problems specifically related to this topic only, and you just do not want to waste your time in finding problems in the books or elsewhere, then you can download my application, whose link is provided in the description box below. Thanks for watching.